Here from McMurry 6th edition chemistry book, chapter 14, number 48 actually, asks us to label the acids and bases and the conjugate acid bases from these different reactions listed here. Now here are some key points to keep in mind. Acids give up H+, bases accept H+. All right? Acids always form the conjugate bases and vice versa, which means the bases form the conjugate acids. So let's look at A. First, we want to figure out what is losing the H+. Okay, it looks like this formula here has one less H over here. So this therefore can be labeled as the acid, and the other substance without any further thinking can automatically be labeled as the base. All right, acids react with bases. Bases react with acids. You never have two acids reacting or two bases reacting. So here, the acid is going to form the conjugate base. So I've underlined it. So this acid, that's key point number 2, acids form conjugate bases. This acid, what's left over after the H+ leaves is an ion, and this is the conjugate base. Okay? Similarly, this base, ammonia, forms NH4+, the conjugate acid. All right, let's look at the pattern again. Here's this next reaction, B. We want to figure out what's losing the H. All right, the H+ is lost by H3O. Okay, it's changing from H3O to H2O, so therefore we can label this substance on the left of the equation as an acid. Okay. The left side of these equilibria are always going to be the acid or the base. The right side of the equilibria is always going to be the conjugate acid or conjugate base. If this is the acid, this therefore must be the base, so carbonate is acting as the base here. Acids form conjugate bases, so H2O is the conjugate base because it's left over after H3O+ reacts. Carbonate is the base. It forms bicarbonate. This is the conjugate acid. All right? So the base always forms the conjugate acid. Acid always forms the conjugate base. Let's look at C. How do we know which of these is the acid? Well, we have to look at the right side of the equation to see who's giving up that H. And it looks like from this formula and this formula, there isn't one hydrogen difference and it's being lost, okay, as we move from left to right. So this formula here can be labeled as the acid, and immediately over here, this can be labeled as the conjugate base. Okay? H2O is accepting the H+ because it's gaining it. Okay, H2O changes to H3O+, so it's gaining an H. Bases, right? As we mentioned up here, bases accept hydrogen, or H+. So this is going to be the base, and the base is going to transform to the conjugate acid. All right, let's look at this next example. Again, we want to think about what's the acid, what's losing the hydrogen. When I look at this formula, HSO3, it's not losing a hydrogen. When I look at H2O, it's losing a hydrogen. Okay, acids lose H+, they become conjugate bases. Okay, acids react with bases, so this must be a base. Okay, bases transform to form conjugate acids. Okay, I hope this small tutorial helps you identify acids and bases and their conjugates in acid-base equilibria. Thanks for watching.